Here the joints are created for hooking up equipment. Each joint has a specific type, which is set using the joint type attribute associated with whatever equipment can be attached using this type. The three main types are implement for a normal 3-point hitch, trailer for trailers that are hitched above the PTO, and trailer low for trailers that are hitched below the PTO. Each joint must contain the index attribute. This index points to the transform group in the i3D file, which determines the position and orientation of the joint. In addition, this must always be rotated so that the x-axis is facing the equipment and the y-axis is pointing upwards. In case of the 3-point hitch, which can be raised and lowered, we can specify two rotating objects. One is directly defined in the vehicle at the starting point of joint and is set using the attribute rotation node. The second point of rotation is used for keeping the equipment leveled approximately parallel to the ground. This is normally located in the same place as the joint itself. This point is indicated by the attribute rotation node 2. The rotation of these 2 points will be determined using the attributes minrot and minrot2 as the rotation when the equipment is up, and maxrot and maxrot2 whenever the equipment is down. The attribute moveTime indicates the time for lifting the equipment expressed in seconds. The tow bars themselves cannot be raised or lowered. That is why we set the attributes allows lowering and allows joint limit movement to false. If a joint also supports a PTO, we indicate the position using the attribute PTO output node and specify the i3D file that should represent the PTO with the attribute PTO filename. If the file path starts with a $sign, this means that this is a relative path to the installation directory of the game and is not relative to the mods folder. The 3-point hitch also has moving parts, which have to be specified. Using bottom arm, we are able to set the lower arm. For that, there's a rotating part that is rotated so that the arm is always positioned along the z-axis of the equipment. Furthermore, it shows the moving part, which is a child of the rotating part. This is always positioned such that the point of the reference node is located directly at the hitch point of the equipment. We define the top link using the top arm. Here we point to another i3D file which contains the data. We further specify the index where the upper link should be located. The 3-point hitch has even more moving parts which move together with the lower links. There's also the option of setting the cylinders and other aligned parts. First, we set these parts using inputs for the moving part parameters. These each consist of an index attribute which defines the object itself. Also, the attribute reference point is used to define the object as well as the moving part you wish to rotate. Thus, when dealing with a cylinder, the bolts are attached to the end of the cylinder. The cylinder is oriented so that the object's z-axis lies in the direction of the object's reference point. The reference point only defines one axis, however. The cylinder can be freely rotated around that axis. In order to prevent this, an object is set up using reference frame, which aligns the y-axis to the moving part. It is also possible to define an indirect orientation. This is required, for example, for these 2 parts. These have to be rotated such that the second arm always reaches the lower link. To do this, we first need to rotate the upper pole clockwise. We set this by putting the reference point to the point below this. In addition, we define the attribute local reference point, which we place underneath the point above this. The second part usually can be defined as another cylinder only by using a reference point. As the next step, the dependencies between the cylinders will need to be defined. To do this, we also add the dependent part attribute in order to specify that the object also needs to be updated when the first one has been updated. In addition, the dependent part has to be updated after the first object. The moving tools elements are the last component of the cylinders. For performance reasons, not all cylinders will always be updated. Rather, this will only occur when something has changed. These triggering mechanisms are the moving tools. Thus, we have a moving tool with the index attribute pointing to the lower links. We add a dependent part which points to the first of the 2 bars so that it is updated when moving the lower link. Using the element motor sound, we define the sound of the engine. This specifies an audio file which is looped repeatedly. In addition, the pitch of the sound is adjusted depending on the engine speed. The pitch is determined based on the pitch offset when the speed is 0. A value of 1 signifies the original pitch of the audio file. Values ranging between 0.5 and 2 are possible. The pitch scale value determines the intensity of the change in volume. This is multiplied by the engine speed in revolutions per second and is added to the base pitch. In our XML, for example, the engine reaches a maximum speed of 2,250 revolutions per minute, which corresponds to 37.5 revolutions per second. The pitch of the sound at maximum speed, thus, is 37.5 times 0.02 plus 1, which equals 1.75. Nonetheless, we are also able to limit the maximum pitch so that the highest pitch is output at a speed or less than the maximum we are looking for. In order to do this, we can use the attribute pitch max. If we are not operating the vehicle, a three-dimensional sound is played. The maximum range from the source of the sound is specified using the attribute radius. In addition, the distance for hearing the sound and maximum volume is specified using the attribute inner radius. From this distance, the sound will continue to converge towards silence as you move closer towards the maximum distance specified.